Welcome guys, today I'm going to be going over how to find the solutions to this polynomial equation on board. So of course pause the video if you want to try it on your own, but there is one really neat trick to it which makes this whole equation very doable, and I will be going over it right now. So as you see on board, the highest degree of this polynomial will be a fourth power, so it is a quartic. And remember that our goal is to simplify this quartic into some series of quadratics. So quadratics which we can easily solve, because for a quartic there is not really a known formula. So what we can do is we can divide probably some of the sides by x, or by some other degree, some x squared, so that we can get rid of these terms. But that also won't really help us. If we just divide this by x or by x squared, we'll have some terms on the right side where we have a constant minus 3/2, and we're not going to be able to make our substitution that we need. But what if we divide by 1? Or not 1, but x over x, like this. This x over x is going to be 1 for real numbers other than 0. And if we divide both sides, we do nothing to the right-hand side, which is the constant. However, we drastically change the left side, which makes it much more simplified. So I'm going to be rewriting it for x squared plus x plus 3, but we're going to divide it, both numerator and the denominator, by x. And then the same thing for the next one, 5x over x squared minus 5x plus 3, divided both by x. And again, as I said, with the right-hand constant minus 3/2, when we divide it by x over x for real numbers other than 0, that is equal to 1. So we do nothing to the constant here. However, now that we divided the fractions by this x over x, look what happens. The x in the numerator simplifies to just a constant 4, and the denominators we get x plus 1 plus 3 over x, and over here, much similar, 5x minus 5 plus 3 over x, and the right-hand constant is still minus 3/2. And now, as you can see, we can make a very neat substitution right here, which is found in both denominators, that is x plus 3 over x. We just let it equal to some arbitrary variable. Let x plus 3 over x equal to t. Now we substitute in t and solve simply a quadratic to find the values of t. So let's do that real quick. We get 4 over t plus 1 plus 5 over t minus 5 is equal to minus 3/2. And this just becomes a quadratic. We can solve, we can find the values of t. Once we know the values of t, we can find all the values of x. So we get 4 times t minus 5 plus 5 times t plus 1 over this factored quadratic, t plus 1 times t minus 5. That's equal to minus 3/2. So let's open some things up, make it a bit easier. We can drag over 2 to both of these sides. So we get first 2 times 4t minus 20 plus 5t plus 5. That's equal to negative 3. Let's factor out this quadratic, because then we're going to make it into standard form and just solve it regularly. We get t squared minus, I believe, 4t, right? And minus 5. That seems correct, yes. Then moving on, we get 8t minus, okay, no, we can first simplify some terms in here. We get 9t here, minus 15 here, so 18t minus 30 is equal to minus 3t squared plus 12t plus 15. And now let's move it a bit over here. We're going to have it simplified to 3t squared. Seems like what, plus 60 minus 45 is equal to 0. And you can in fact factor it, or you can use quadratic formula. I'm going to factor it without, seems like it's going to be 3t times another t. Yeah, and here will be 5, and here will be minus 3. I already factored it previously, so I know the answer. But if you want to use more reliable quadratic formula, then you can. This, in fact, will factor out into our standard form quadratic, and that makes the values of t equal to 3, and also seems, wait, no, not plus 5, plus 15. Yes. It's going to be 3t plus 15 times t minus 5. And now we'll make the values of t 3 and minus 5. So move over 15, get minus 15, divide by 3, minus 5. You know it's minus 3. Yeah, it's going to be 3 and minus 5. Those are the values of t. Now that we know those values, we can solve again for x, because we let t equal to x plus 3 over x. And let's do that right now. All right, so remember that t is equal to this little sum of the x, or with a common denominator, x squared plus 3 over x. And we have found the values of t just now, which are going to be 3 and minus 5. And now we can just plug in t into here and solve for x, and we will be done with the problem. So let's try minus 5 first. We get, for t equals minus 5, we get that x squared plus 3 over x is equal to minus 5. So that means x squared plus 3 is equal to minus 5x, or x squared plus 5x plus 3 is equal to 0. And from this, we can just use discriminant, because this does not factor nicely. We get that the discriminant is going to be b squared minus 4ac, which is 25 minus 12, which is 13. So the x values will be, seems like, minus b, plus and minus the root of the discriminant over 2a, and that will be minus 5 halves plus or minus half of root 13. And those will be two of our solutions. Now we can do for t when it's equal to 3. Let's have it here. It's the exact same procedure. We get that this x squared plus 3 over x is equal to 3. Therefore, x squared plus 3 is equal to 3x. Move it all to one side. X squared minus 3x plus 3 is equal to 0. So again, we use the discriminant, which is going to be b squared minus 4ac, again 12. But we get a negative discriminant. It's going to be 9 minus 12, which is minus 3. So these are actually going to be our complex solutions to the equation, which will be minus b plus or minus the square root of minus 3, which is just I root 3, the imaginary unit, over 2, which is the real part, 3 halves, plus or minus the imaginary part, I root 3 over 2. And those will be our 4 solutions. In fact, let's put a box around them. We have our real solutions, minus 5 halves, plus or minus half of root 13, and the complex solutions, 3 halves plus or minus I root 3 over 2. And yeah, just like that, using a very clever method of dividing by 1, which is not actually 1, but x over x, we are able to make a substitution, which makes our life much easier. And then we are able to find the 4 solutions of this quartic polynomial. And that is it. Thank you for watching.